here we have group number 12. We are going to be presenting about Faraday's law and the electromagnetic induction. But before we start this presentation, I want to introduce myself. I'm Jean Dieu Jeremy with the reg number 22 30 13 13 0. 22 30 13 13 0. Okay, thank you. I think it's not your first time to hear about the term electromagnetic induction and Faraday's law. I think you've heard about electrical power plant and how it works. You've also heard about Faraday's law and how they are applied in electrical power plant, in generators, and other applications. So, in our presentation, all of those you will be understanding. And then, dear runners, within this lesson, we will be basing on simulation, where you are going to see how simulation will be applied in teaching this concept. So, thank you. I can welcome my colleague to come and continue.
Good morning.
Good morning.
My name is Jean Baptiste. My leg number is 2172 55809. I'm going to tell you our objective of our lesson today. The first objective is, by the end of this lesson, the students will be able to understand electromagnetic inductions. Everyone will be aware of the meaning of electromagnetic induction. The second objective is to explain Faraday's laws. I think by the end of this lesson, everyone will be able to state or to explain very well the Faraday's laws. The third objective is to identify the factors affecting induced current. Everyone will be able to identify those factors after these reasons. The last objective is to apply concept to real lives. At the end of this lesson, everyone will be able to know, to be aware of where we can apply our lessons. I invite you to be attentive for this lesson in order to be able to be, if you know they after the lesson, these outcomes. Take with the following, this back and come and continue by introduction.
So, thank you very much. Good morning. So, my name is Eric Tisenge with the reg number 22 30 11570. 22 30 11570. So, I'm going to proceed with the simulation-based learning. Here there is the simulation phenomena, where we are going to simulate, to see the model, to imitate. The model is showing how the real situation could be. About this, the topic you have chosen to tell you. So in this scenario, I'm going to to change something. I'm going to change like three main, four main things in this, and you are going to see what is changing, how is it changing. If I change this, what is happening on this scenario. So, first of all, okay, here we have this one, we have this one, this and this. So all of these you are going to notice what they are at the end of this, or through this lesson. So if we open here, you see, we open here like this, and we see something shining. One is rotating like there, and something is shining. So if I increase the amount of water, you see what is happening. Everyone can write down what is happening. I'm increasing and something is happening. So let me change the bar magnet to F and see what could happen. If I increase, something is it? Are you getting the change?
Yes.
Very good. Let's increase the rope. The rope. The rope is to say the number of turns in this rope. For example, if I make this 2 1, you see, there is one rope here. One rope. Okay? Let me increase 2 2, and you see, it is 2, now something changed. Have you noticed? Any change? 2 3. Okay? Oh. Now it is changing somehow. So you can notice what you were observing, and you will get the answer from this module. So let me change the group area. Area between this group. And increasing. But increasing, something is changing. Increasing, something is changing. Okay? Are you getting something? Even reducing, you can see something is changing. So, this was like this is the situation that is showing what is taking place whenever this situation is applied. You are going to notice where this situation is applied for this model. So, thank you very much. That was my role in this group. I can invite another one. Proceed. Thank you very much.
Okay, thank you for welcoming me back again. I can proceed with okay. I can welcome the field to continue and explain what the process of electromagnetic motion is. Thank you.
Good morning. Good morning. Yes, I'm Delphine Mukanase with the leg number 2237327. Okay, I'm going to talk about the Faraday's law and the electromagnetic induction. We are going to explain what we mean electromagnetic induction. When we say electromagnetic induction is process of producing electric current in the conductor due to the change of magnetic field. Yes? Okay. When you change magnetic field, it induces electric current. Electric current process produce a magnetic field. When electric current flow through the conductor, it generates magnetic field around the it. It generates magnetic field around that the conductor. So for the higher electric current produces strong magnetic field. Yes?
Yes.
For changing the magnetic field, also induce electric current. According to the Faraday's law, changing of magnetic field in closed loop induce electromotive force. Stronger the rate of change of magnetic field induce or produce stronger induce electromotive force. Yes?
Yeah.
Let's continue to the Faraday's law. Faraday's law states that the magnitude of induced electromotive force is directly proportional to the rate of change of magnetic flux within the circuit. Yes? By the formula, electromotive force is equal to the negative change in magnetic flux within in terms of time. This negative sign shows the direction. Yes? In terms of the number of turns, electromotive force is equal to the negative number of turns change in magnetic flux in terms of time. In the video we showed before, when the number of turns increase, electromotive force produced also increase. When the number of turns decrease, also electromotive force produced decrease. Yes? Yes. Let's divide another continue.
Okay. Thank you, Delphine, for your explanation. And addition to what she has been explaining, using the simulation as we introduced it, that our lesson will be simulation based. So I want to highlight and explain more about that Faraday's law by using this simulation, right?
Yes.
So, as Eric has did this area, here we have, you can see this is source of water. Yes? This is source of water which will be there just as to turn that magnet. You can see that this is magnet, and this area will be area where we'll be having magnetic field. You can see that here we have coil, and here there is bar. Can you see?
Yes.
So here on this side we have where we can increase and decrease the magnetic strain or the field strain. Here down we have where we can increase the loop area, and here you can see that here there is even number of electrons. You can show electrons here moving within this loop. Okay. Now here we are going to turn on. This week you will be turning the water. Can you see? Can you see something?
Yes.
What do you see? I want you to compare the rate of this turning of this magnet with the brightness of this bulb. Are you comparing? You can see that when, as this magnet turns faster, you see, as it is changing faster, the brightness increases. What does it imply relative to this formula? How can you relate this? How can you relate the phenomena that is happening here with this formula? You can see that this is This is magnetic flux. And you can see that this term is relating the way magnetic flux, or the rate of magnetic flux, where magnetic flux changes with the time. And you can see that as the rate increases, the brightness increases. And that one exactly matches with this law, where the rate increases as the induced current increases, as EMF also increases. Okay, now I can reduce, and you see the brightness. Can you see? Can you see? I can also increase field strength, and you see. What do you see? Is anything changing?
Yes.
Can you see changes?
Yes.
Now I can here reduce the area. What is happening? Is the brightness increasing or decreasing?
Increasing.
Now let me increase. Is it increasing or decreasing?
Increasing.
So this is increasing. This was what about the law has been stating.
Stating.
And in that context, we are going to continue by explaining the main factors that affect the induced current. As we have seen that induced current is the current that will be produced due to the changing of magnetic field. You can see that we have been changing. Now we can now continue with factors affecting what? Induced current, as well as induced EMF or electromotive force. So here I'm going to welcome my colleague come and continue with explaining the factors. Now you're welcome.
Hello,
Hi.
my name is Emmanuel Bisha. Is rate number 2230 15533. 2230 15533. I'm going to proceed with the factors affecting induced electromagnetic force or induced current. As we have seen in Faraday's law, we have seen that we have the electromotive force and the magnetic flux and also time. I'm going to talk about the rate of change of magnetic flux. This is whenever we say rate of change of magnetic flux, in this formula it is the whole disk. As the magnetic flux changes, the more also we get the induced EMF. Whenever we say magnetic flux, means the magnetic field lines which are passing in the magnetic field. As long as the magnetic flux gets closer to the coil, the more we get, the more electromotive force or the current. As you have seen in the recent model, you have seen that whenever we are increasing the number of turns here and in the coil, and also we increase the speed of water or the depth of water, the revolution per minute within the magnet also increases, such that it rotates, it revolves more, and also we get the more current. Here, in addition, we have seen that again. Let's proceed. is the factor affecting the induced electromotive force. Well, I was talking about rate of change in magnetic flux. I'm going to use that simulation to show how the magnetic flux affected the change in electromotive force. Here we have the rotating magnet and we have the bar magnet strength. As long as we are increasing the strength of magnet, you see the current is increasing within the bar. And as long as we reduce, you see the current also will reduce, which means that the more we increase the strength of magnet, which is the magnetic flux, the more we get the more current, which is the electromotive force. Thank you. Let me welcome another member. Proceed with the another factor which can affect the induced EMF.
Once again.
Morning.
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 So I am by the name of Shimukubina with red number 230. 13345. Now I'm going to continue with those factors affecting induced current or induced electromotive force. Yes? Now, as we have seen in our model, we have different factors. We have the magnetic flux, we have number of turns, we have magnetic field, we have what and what. Yes? Now, I'm going to focus on number of turns. Yes?
Yes.
I think everyone here have been shown about it, number of times where they are. Yes?
Yes.
I want one of you to come and show us where we have turns in our model. Anyone? Who can come and show us where we have turns? Turns or loops. Desiree, may you come and show us, please? Now, flowers to him.
Flowers.
Now, we have turns here, yes?
Yes.
Now, we are going to see how those turns can affect the current that will be produced, yes? We are going to see what happens when we increase turns, yes? What happens when we decrease turns. Now, you see now we have 3 turns, yes? I'm going to now we have 3 turns there, yes? I'm going to decrease it to 2. And you tell me what you see. Now I go to 2 turns, yes? I go to 1 turn, yes? Then you increase it to 4. Do you see?
Yes.
Now, I want you to tell me what happened when we decrease turns. Valentino, may you tell us? Yes, Eli?
Intensity of right decrease.
Sorry?
Intensity of right decrease.
Now, when we decrease turns, the intensity of the light also decreases, yes?
Yes.
Also, when we increase the number of turns, the current that will be produced also will be
Increasing.
decreased, yes? Now, that's how turns will affect the current that will be produced in our model. I think everyone is now have clear understanding, yes? Now, thanks for your attention.
Good morning, everyone.
Good morning.
Now we are going to see after looking to the electromagnetic induction, now we are going to see what are some applications of this electromagnetic induction. Do you think these have any application in our real life? Yes. My rate number is 13 17 972. I am by the name of Rakora Amos. Rakora Amos. So we have seen electromagnetic induction, we have seen this simulation. Now we are going to ask ourselves if they may have any application in our real life. Yes? So the electromagnetic induction have several applications in our daily life, like producing the EMF or electromagnetic force or current we normally use in our daily life. So let us see the first application in generator, electric generator. That next slide. Yes, electric generator. The electric generator is the tool which use this Fraday rope to produce electric current, where the rotation of magnet induce an electric current which may produce, which we can use now in home, in any activities. In several activities we can use electric current which can be induced by electric generators. So in electric generator there is a coil which may rotate, then mechanical energy change it into electric current to be used. Also, this law of Faraday can be used in electric transformer. You know, when the current is produced from any source to be supplied in a society, it is not used directly, but it has to pass in transformer to be changed, like step up or step down. So, due to this law of electromagnetic, due to this law of Faraday law, the AC current comes to the first coil of a transformer. After reaching to the first coil of transformer, it is transformed into the AC comes transformed into a flux, then reaches to the second coil, become an AC or a current, which can be now sent as step up or step down, then to be supplied in a community, in a village, or in anywhere we have to use this current. So before an AC current, alternating current, after coming in a transformer, it used this law of Faraday to be transformed into an AC or into a voltage, then to be used to be supplied in the community. So this is one of the application of Faraday's law. Thank you for your kind attention. Thank you.
Thank you.
Okay. Thank you very much. Now we are concluding our lesson of this session. You remember that before starting, we have introduced by a lesson by explaining you what electromagnetic induction is, and then with Faraday's law, I want to someone from you to stand up and tell us maybe any two things that can be taken as a takeaway of this lesson. So if you are there, you can just get up and help us. Is it, okay?
Thank you so much. For me, I have an idea of how I can build electric power plant at home. I can build a simple one from Faraday's law, because I understand the concept. I can use to build a simple electric power plant at home, so that also I can reduce the money I use in buying electricity and so on. Thank you so much.
Okay, exactly. Okay, this was all about our session, and I want you, when you reach home, so you work on this, you think, and figure out how we can use electromagnetic, Faraday's law of electromagnetic induction, and how you explain how it is applied in electrical power plant. Thank you for this session. This was one about our presentation. Thank you.
Say.